Hello, I'm David Mollick with Makerspace 307. I'm going to be an instructor for this class, Intro to 3D Printing. Got a quick PowerPoint presentation we're going to go over, give you an understanding about the class. So when you complete this class, you should be able to define 3D printing. You should understand some of the limitations of 3D printing, what it can't do. You should be able to understand the benefits of 3D printing, essentially why you should want to use it. You'll learn how to design an object and objects for 3D printing. We're going to be using Tinkercad for this. We've got a little sample project that'll get you started. We're going to learn how to use 3D printing resources that we have at Makerspace 307. So it's going to apply specifically to us, but broadly to other spaces and individuals if you have your own machines. So what is 3D printing? This is a question that we get a lot. A lot of people don't understand exactly what it is or why it should be interesting. So the kind of broad description of it, 3D printing, it's also known as additive manufacturing. It's a manufacturing process. It creates objects through layering a build material to build a physical object from a digital file. So that's kind of a mouthful there. It's a little bit hard to understand. So essentially 3D printing that we're going to be talking about uses a filament. So this is a PLA. It's 1.75 millimeters in diameter. So kind of like a weed whacker line. It's a little more brittle than that. So we take this, we run it through a machine that's called we run it through a portion of the machine that's called an extruder, which is just a motor that runs it forward and back. And from there, the extruder feeds it into a hot end. So a hot end consists of a couple of parts, but the primary ones that we care about are the heater block and the nozzle. So essentially, the heater block heats up. It actually melts the plastic into a molten state, and then it forces it out with the help of the extruder, forces it out the nozzle, and then this goes around and essentially traces the outline of an object layer by layer and builds it up to your physical object. So switching back here, so that whole workflow starts with 3D file. You have to have a design file for 3D printing. You have to start with something. So you take your 3D file that you either found or designed yourself. You send it to a slicing engine in a slicer program, and what that'll do is that'll take that file, and based on the input you give it, it will slice that object into little teeny tiny layers, about the thickness of a sheet of paper. Then that slicer will look at each of those layers and generate something called G-code, which is a standard CNC machine language that describes how machines are supposed to move. And it essentially it basically reverse engineers, starting from nothing, how you get to that layer. And it generates a G-code that gets sent to the machine that tells the machine how to trace each of those individual layers and build them up while extruding plastic. So this primarily applies to FFF or FDM type printers. So that's fused filament fabrication, which is a kind of a general term for this type of machine, or FDM, fused deposition modeling, which is a trademarked term, mean the same, or they describe the same functions, but FDM is only going to be one specific brand type of machine, where FFF can describe anything that uses the same process. So some of the benefits of 3D printing are you can accomplish fast and low-cost prototyping. You can create one-off, so if you just need one of something, it's fantastic at that. It's great for mass customization, so if you have an item that you want to change one little thing on, whether it be something like a shoe that you have some specific size that you need that's a non-standard shoe, or you want to put your name on it, it's fantastic for that. So it's also great for small-scale production. For the most part, when you're manufacturing plastic parts, you need to have somewhere between 700 and 1,000 units for injection molding to be cost-effective. By the time you pay for your molds and all that. So it's great for that. It's also good for production of complex organic shapes, and we'll show some examples of that. Because you can essentially create interlocking parts and pieces. You can't do subtractive in the same way. it's great for that. It's also great for distributor designs. If you have a design that you want to share with the world, or if you have a design that you want to be able to sell, you don't necessarily manufacture a product, you can sell your design as opposed to selling the product. So some of the limitations of 3D printing actually kind of play in or go well to some of its strengths. So your cost per part is fixed. What I mean by that is if you're producing a widget, let's say, and you have a part that's going to take, let's say, an hour to produce on a 3D printer and cost you 50 cents a material. To produce one part, that's what your cost is, cost per part. You produced 100 parts, your cost is still 50 cents per part. Still takes the same amount of time. With injection molding and other production processes, your cost for that first part might be $20,000, but by the time you get up to, let's say, 10,000 parts, your price per unit may have dropped down to 1 or 2 pennies. So it can vary wildly, where with 3D printing you are stuck with it always taking the same amount of time, costing the same amount. So there are also some variable conditions in manufacturing environment. What I mean by this is the hobby machines that we have aren't true industrial production machines, so there are going to be some failures. So you produce, let's say you print 10 of an item, you might have 8 of those turn out perfect, but 2 of them might have some issue caused by, air movement causing the part to cool irregularly, your build plate not being up to temperature, being too hot, being too cold, there being some dust on your filament. There's a lot of things that can go wrong, and because we're not talking industrial machines, we don't have industrial quality control essentially. So for the most part, you're also limited to plastics on these types of machines that we have in the makerspace. There are some available that you can print materials that you can end up with metal parts, but they're a lot more expensive and require a lot more post-processing work. And then of course you have to start with a 3D file. Some other manufacturing methods, you can actually make stuff without having to have a computer generated file. So now to talk about 3D printing and what you can do with it, this is where it gets a lot more fun. So you're limited only to imagination of the designer and materials used. So a lot of these examples are made on machines like we have at the makerspace. There are also some that were made through services that everyone has access to. So the first one we're going to discuss is Jewlery. So Jewlery is a pretty interesting application for 3D printing. This is where the mass customization comes in. If you're making a ring and you want to make a specific custom design for somebody, instead of having to generate dozens and dozens of models and molds to then cast, you can actually start with a digital file and go directly from digital file to a wax or finished product. So this also kind of illustrates some of the organic shapes that you can accomplish with 3D printing. So I've got a really bad example. These were all done with on the pictures. These were all done with an SLS type of process where you have a fused powder that is fused with a laser and built up layer by layer. So here is a little bracelet and similar in design that was done on that I did a number of years ago on a really low quality printer, but you can see it even has the ability to generate pretty decent results for jewelry. So then of course there's toys. You can make tons and tons of plastic toys. That's what a lot of people think of when they think of plastic and 3D printers. So Object, the little purple guy there, he's actually a building toy that's modular, so you just print out more parts and pieces, and he needs a new helmet, you can have a helmet. If he needs to have some armor, you can design and print some armor that snaps onto him. So it's a modular toy that allows customization. The other object, a little buggy there, is actually a remote control car that was that started out life as a production car, just made by a toy company that they tore all the parts out and essentially built a custom dune buggy toy around the parts that were in the commercially available model. I've also got another toy here. So like here's a big Lego guy, a big minifig, I guess. And so the cool thing is someone designed this, and it's actually able to be taken apart, swap parts around. The arms are removable, the hands are removable. Got another guy here, so let's say we want him to have a green arm and a red arm. So there's, once again, plenty of fun things that can be done with 3D printing when it comes to toys. So you can also make consumer products, so they're not direct. You don't have to use them just for toys. You can use them for anything that people may want. So all of these examples are actually produced on commercial machines. Got the guitar there, which is really cool skeletonized instrument. We've got a lampshade, and the object in the middle is a Veroni bottle. So it's actually a really cool part that was produced in stainless steel, and it's a bronze infused stainless steel. So they sinter the product, and then they to make it stronger, they fill any of the voids in with bronze. You can also make functional objects. So the small small object with the can of Dr. Pepper is actually a 3D printer that was 3D printed. Other item is a quadcopter frame that was 3D printed. Then there are also a lot of other objects, like this guy right here is actually a filament holder that was designed specifically for a model of 3D printer that I personally own. You can also create, here's a design that somebody else has made that's for painting minifigs, mini figurines. So there's plenty of things that you can do with it for functional objects as well. So let's see, moving on. It's also great for educational aids. So with 3D printing being hyper specific, you can design things that specifically apply to particular units in a classroom. So we've got some math manipulatives. We've got manipulative with gears that help explain gear ratios. We've got a dinosaur skeleton that gives you better understanding of those. And then my favorite on this is actually the white object in the back there is a scan from NASA that was made available, and that's Gale Crater on Mars. So if you're discussing a unit on, let's say, space, and you happen to talk about the rovers on Mars, you can actually have a printed out object that the students can actually look at and get a better understanding of what this Gale Crater that everybody's talking about is. So a common question we get asked about is with 3D printing is, can you make guns? So short answer is, if it's at Makerspace 307, no, you cannot. But I like to use this as an example to the question of, why would you want to make a gun when you can make something as cool as what this gentleman has done? It's a paper airplane machine gun. And those are paper airplanes flying out of the end of that. Just a second here, and I'll actually show you how the gun is working. It actually takes the sheet of paper and folds it and spits it out the end. That's one of the coolest things about it. So this is a very, very complex item that this gentleman designed and created with 3D printing. So, long answer, guns have been made with 3D printers. There's not really any reason to. You can make so many things so much better out of actual materials that are suitable for it, using metal and all that. Like I say, Makerspace 307 policy is we don't make weapons. So at the end of the day, the only true limitation of 3D printing is your ability to design. I personally feel it's very important for anybody who wants to get started in 3D printing to quickly understand how to create an object. Because a 3D printer that is run by somebody who has the ability to design objects is a tool. A 3D printer run by somebody who just prints objects that they find on the internet is more of a toy. So we advocate creation of your own designs as opposed to consumption of other designs. So there, that's my little presentation. If you have any questions, please let us know. If you haven't enrolled in our online class and are interested in it, check out the link in the description. It should be there. If not, contact us through our contact page on our website, and we can give you the instructions on how to do that. Thanks again.